Okay, so we are doing our writing hydroelectric power. Our learning target is, okay, as of here. Learning target, research hydroelectric power and gather information I can use to write my informational article. So for Friday, we're going to reread pages on the class Campus pages 2 through 3, and we're going to annotate, which means highlight or underline, information you will need to write your article. So we're going to highlight how hydroelectric power works. We're going to highlight the benefits, and we're going to highlight the problems. Okay? So, I went too far. Page 2. So yesterday, what did we highlight? Some of the stuff. What did we highlight for how the hydroelectric power works?
We have to read the first part.
So let's reread. Ready? Top of hydroelectric. Let your book open. Finger on the first paragraph. Ledger quickly. Yeah, paragraph number 1. 42 ledger. Okay. Hydroelectric power. How it works. So just how do we get electricity from water? Actually, hydroelectric and coal-fired power plants produce electricity in a similar way. In both cases, a power source is used to turn a propeller-like piece called a turbine. The turbine then turns a metal shaft in an electric generator. The generator is the motor that produces electricity. A coal-fired power plant uses steam to turn the turbine's blades. A hydroelectric plant uses falling water to turn the turbine. The results are the same. Yes, Dylan.
Can I go fill up that water?
Not right now, okay? In a minute. Okay, now let's reread page 43. Okay, so finger on paragraph 2. Ready? A typical hydroelectric dam is built on a big river with a large drop in elevation. The dam stores lots of water behind it in the reservoir. Near the bottom of the dam wall, there is the water intake called a penstock. Gravity causes the water to fall through the penstock inside the dam. At the end of the penstock, there is a turbine propeller, which is turned by the moving water. The shaft from the turbine goes up into the generator, which produces the power. Power lines connected to the generator carry electricity to your home and mine. The water continues past the propeller through the trail race. The water then flows into the river past the dam. By the way, it is not a good idea to be playing in the water right below a dam when water is released. Pumped storage, reusing water for peak electricity demand. Demand for electricity is not flat and consistent. Demand goes up and down during the day. Overnight, there is less need for electricity in homes, businesses, and other facilities. For example, at 5 p.m. on a hot August weekend day, there may be a huge demand for electricity to run millions of air conditioners. But 12 hours later at 5 a.m., not so much. Hydroelectric plants are more efficient at providing for peak power demands during short periods than are fossil fuel and nuclear power plants. One way of doing that is by using pumped storage, which uses the same water more than once. Pumped storage is a method of keeping water in reserve for peak periods of power demand. Pumps move water that had already flowed through the turbines back up to a storage pool above the power plant. That happens when customer demand for energy is low, such as during the middle of the night. The water is then allowed to flow back through the turbine generators at times when electricity demand is high. Okay, now, stay on page 42 and 43. Thank you. Okay, so now, who remembers what we highlighted, how it works? So on your organizer, on this paper, I want to start filling in that first part, okay? So power source. So what do we need to write in for power source?
Hand stop generator turbine and drum.
What is it that we're using? What is it called? Stay in your seat.
The generator.
Hydro.
Electric.
Thank you, Dylan. Hydroelectric power. Okay, so up here, power source. Write it in. Hydroelectric power. Hydro. And it's on your book if you don't know how to spell it. Electric power. Okay? So for each power source, hydroelectric plants and wind turbines, write the evidence you marked in the text next to the idea it supports. So for this part, the idea is how it works, right? Okay, so let's try to make 2 points, 2 sentences for how hydroelectric power works. Dylan.
Generator produces wind power carried by power.
Cool. So do you think that we should use what's in the image as well? How it has like step 1, step 2, step 3? Okay, so let's use that. So let's say step 1, instead of saying step 1, we can say first, right? Okay, first, comma, write it down please. First, comma. I'll put the camera on so you can see it bigger. Okay, first. What's step 1? How does it work?
Generator produces power.
No, that's step 3.
Oh.
Ariana?
Water
A typical hydroelectric dam is built on a big river with a large drop in elevation.
Okay, where'd you put it? Second sentence? No, first.
No, second. Third paragraph. First paragraph.
No, second paragraph,
Yeah, it's
first
second.
sentence.
Oh, second paragraph, first sentence. Sorry, I was looking at paragraph 1. A typical hydroelectric dam is built on a big river with a large drop in elevation. Okay, so first, do we want to use quotes or do we want to reword it and summarize it in our own words?
Reword it.
Okay, reword it. Let's do it. Okay, so what can we say? So first, the hydroelectric, try not to use too much space because it's kind of a lot of steps. First, the hydroelectric dam is built instead of saying big, we can say large. On the large river, that drops in elevation. That one was a little bit harder to summarize. Period. Good. Keep writing. Marley, your paper. Thank you. Keep going. Okay, so then for second, we can actually use the bubbles for how it works, right? Ledger?
I got one. I put some like.
Sorry. Ariana? No.
At the end of the penstock, there's a turbine propeller, and it's turned by the moving water.
Good, I like it. Okay, so at the end of the penstock, moving water turns the Marley, put it away. Thank you, Thomas.
Thomas.
Yeah. Thank you, Thomas. What else did you say, Ariana? Moving water turns the propeller? Turns the turbine propeller and then we can say period.
Yeah.
Then, what's the last part? For how it works.
How do you have
I have more space than her.
Then the generator
Powers which is controlled by the power lines.
produces, so it creates. I told you don't write too big. Try to as fast as you can. That's not too big, so yeah. Produces power out to the power line. Period.
I have like room for one more word.
Okay, I think that's good for how it works.
I really
don't
always say the bottom.
I won't erase it. That's okay. Okay. Dylan, focus. So we have a little pause that doesn't mean you start talking, okay? Okay, we're gonna stop right here, okay? So the benefits and the problems we will work on Monday. So your paper, so just make sure your name is on your paper. Then just put your paper in your book and close your book and put it away.
We're done? It's been 30 minutes already.
Well, we started a little late, so it's been 20 minutes. But it's time to start on ELA groups, okay? So,
Eli group.
you have, you're gonna go to Miss Jacobson.
Oh yeah, Jacobson's. And then after
And-
this we're going to lunch.
Yeah, and Mohammed is taking a break with Miss Martinez, okay? So tell Miss Jacobson. And Enoch's not here, I don't think, so
Sophie Thomas, what are you doing? This isn't your chat time. I said ELA groups. Thank you, Noah, for getting started. Ledger, this isn't chit chat time.
Miss Tapia.
Yes, Thomas.
Quickly question.
Thank you, Sophie.
Can